Hello everyone, good afternoon.
Good
Good
afternoon.
afternoon,
Good
sir.
afternoon, sir.
Okay, so today we have week 6 solving this session. Yes. Okay, so every one of you please go to joinpd.com and enter the code on the right top of my screen, which is XYSLZO. Okay. Type it. Okay, so once you join that, you will be seeing questions on your screen. You have to, there will be option like shown here on the right bottom of your screen to answer the question if you are on your mobile phone, and if you are on your laptop or desktop, the answer portion will be shown just on the side screen of the question. Okay. Am I audible? Hello.
Yes, sir.
Okay.
Yes, sir, you are audible.
Okay, so everyone please join. Let's just wait for a minute so every one of you join. We can start. Okay, so let's move to our first question. Consider the numbers. You have only these 5 numbers: 0, 2, 4, 5, and 9. And you have to make 4-digit numbers with repetition not allowed. So how many 4-digit numbers can be made from these numbers without repetition? Okay, let me just set timer for it. I think 3 minutes will be enough.
Where to enter the answer?
Sir, in this session, aren't we solving doubts of the student? We are just solving the questions with you.
Yeah, after these slides, we will take your doubts.
Okay, sir.
Okay, and yeah, for whoever have joined recently, go to joinpd.com.
But
And
this question is not appearing in jointpd.com.
you have entered this code XYSLZO.
Yeah.
18 of 25, I think people have started answering also.
Okay. Yes, I made some mistake. XYS LPO. LZ.
Most of you have answered. Let's just wait 40 seconds more and move to solution. Okay, let me see your responses. Most of you have answered 96 and 120 also. Okay. Let's move to a solution. So see, you have to make a 4-digit number. So we have to fill those 4 places with the 5 even numbers, right? But the first place cannot be 0, because if I write number as 0, 1, 2, it will be a 2-digit number, not a 3-digit number. So in this case also 0 cannot be at first place. So I can fill the first place with only 4 of these numbers. So I have 4 ways to fill that place. Similarly, for the second, I have already used one number in the first place, but here 0 can also be one of the possibility. So again, I have 4 ways. Similarly, for the third and fourth place, I have 3 and 2 ways respectively. And multiplying all them, I got 96, which is the correct answer. Yeah. Any doubt in this, or shall we move forward?
No doubt, sir.
Let's move to next one. Okay, this one is similar to your graded assignment one. You have to find how many 4-digit numbers, again without repetition, which are divisible by 4. Just take your time to calculate.
Hello.
Yeah,
Audible, sir.
I can't hear you. Can you speak a little loud? Hello.
Okay, sir. Thank you, sir.
Yeah.
Thank you. Yes. Thank you, sir.
Just let me know if you need more time on this question. After this time, we can extend it. I think just in a minute we can move to solution. Most of you have answered it. Okay, I think we can move forward. Solution. Okay, and answers are very scattered for every one of you. Okay, let's move on. Okay, so first you all must know the divisibility rule of 4. It says that the last two digits of a number, if they are divisible by 4, the whole number is divisible by 4, right? So using the divisibility rule of 4, I can say if my last two digits are either 0, 4 or 20 or 24, 40, 52 or 92, any of these 6, then my number will be divisible by 4, right?
So I don't know about the divisibility rule of 4 actually. How are you getting this number? 0, 4, 20, 24, 40.
It's divisibility rule said that if the last two digits of a number are divisible by 4, then the complete number is divisible by 4, irrespective of number of digits. You can
No,
try.
I mean the last number can be 0 to 4. I mean I have 5 choices, right? The last number can be 0 to 4 because 4 3s are 12. That checks it. Then there is 4 5s are 20. Then 0 can be there, and only 4 can be there because 4 into 1 is 4. But what about these two pairs of numbers, that is 0 4 20 24 40 52 and 92? How are we getting this?
Okay, so it's the divisibility rule of 4. Let me just give you. I want to do the proof. Just we can do it by examples. Okay. Okay, so let's write any number. Okay, let me write 304. Okay, 320, 426, 532, and one more. Let's consider 772. Okay. So how would I know which one of these are divisible by 4? Okay. So for that, I just look at the last two digits. Okay. See here, it's 04. 04 is divisible by 4. Yes, it is divisible by 4. So I can say that the whole number 304 will be divisible by 4. You can also check it, like 4 times 76 is 304. Okay. Again here, see the last two digits, which is 20. 20 is divisible by 4. Yes, it is divisible. Then I can say that 320 is also divisible by 4. You can say it like 4 times 80, right? Now here, if you see last two digits are 26. Okay, since 26 is not divisible by 4, right? It will be something 6.5. So it's not divisible by 4. So I can say that 426 is not divisible by 4. And similarly, you can do it for these two. So that's the divisibility rule of 4.
Is there any rule for it? I mean, formula for finding these numbers for any digit? I mean, for x4, for example, 7. If I want to find the numbers
for
which are
7,
divisible.
for 11, for
Table of 4.
13, for 19. How to do that?
Can
By
you
only
repeat?
4.
Table of 4.
By only 4. Yeah, only 4 you can do it, right?
Table of 4 is not actually right
No,
because not all the numbers.
How to get the
Yeah, yeah.
divisibility rule for any
Correct.
number?
Yeah, that is the
For
question.
any
Because-
Yeah,
number.
table of 4 is right. No,
because,
last
sir,
two digits only
sir,
we need to check.
Sir,
Uh,
No, all the
these-
numbers are not included in table of 4,
no,
no?
no, no.
So
Yeah, these divisibility rules are, I think, are already taught to everyone in class 5th or 6th. And
No,
these
sir.
are
Yes,
already
yes.
general.
Yeah.
No, sir, not for 4.
Yeah,
There is no divisibility rule for 4.
there is. I just showed you. Tell me any number. I can tell you if it is divisible by 4 or not.
No, I cannot.
take 7.
7.
No, 7 rule is
7
there
is,
for 7. For prime numbers, rules are there, sir.
no. For 7, just
But
for
not
7, I can clearly say I don't need any rule for it, right?
But no, sir. We have learned
Tell me.
that any
No.
number will be divisible by 4 when it is divisible by 2 and 4 both.
Yeah, you can also read. That's also one kind of rule. Also, you can do it by that as well. Also,
Because
see here.
we have learned the rule for the prime numbers divisibility.
And what
Not
is that?
for-
I don't even know that.
Okay, so 4. Consider any number. Okay, just
Okay.
now take any
Okay.
number you say. Okay.
Okay.
Okay, if I have to tell if it's divisible by 4 or not, okay, I will just consider these two digits 2, 4.
Mhm.
24 is divisible by 4. Yes.
Yeah.
Then I consider the complete number is divisible by 4. And also check it if you want.
Yeah, but how am I finding this 24? I mean, for 7.
24 is
For
the last two digits, right?
okay.
Last two digits. For 7, there is, I don't think there is a rule, but that's a bit complicated. It's not used in general. We have rules for, okay, let me tell you the rules. For 3, we have
Okay.
that, for 2 is that last digit should be even.
Even. Yeah.
You can say it can be, should be like 0, 2, 4, 6 or 8.
We
10.
have
Right.
learned. We have learned for 2, 3, 7, and
For
11.
For 3, we have sum of digits should be divisible.
divisible by 3. This is the rule.
Yeah.
But then in this case, sum of digits should be divisible by 3. If I get a question on 3, then I don't know the exact numbers which I'm getting, right? I'm only knowing how many combinations possible. And how am I check? How
So we
am
are
I going to
getting.
check?
Okay. Let's just take this question. Okay, you have 0, 2, 4, 5, and 9, right?
Yeah.
And I have to make 4-digit number.
Okay.
So first I have to select those 4 numbers out of these 5 whose sum is divisible by 3. Okay. So as an example, if I take
0, 2, 5, 9. All are divisible by
4, 5, no, all these 4. But I will see if I use these 4 digits, how I
I don't
arrange.
get it. 4, 5, 9, 9, 0. How are you extracting this?
See, 4 plus 5 is 9, plus
Okay.
9 plus 0. It's 18. Its sum is divisible by 3, right?
Okay. Okay.
So
Yeah.
if I arrange this number in
4, 5.
any way, it will divisible by 3. Okay.
Okay.
All these two. So because sum is always divisible, sum is 18 here, sum is also 18 here, sum is also 18, right?
Okay.
Yeah, this is the rule, sir. This is the rule.
So any other pair, if you can think of, I don't think there is any other for 3. 0, 2, 4, 6. Yeah, there you can also do that. 2, 4, 9, and 0, right? Its sum is 15, and it's also so if I arrange these 4 digits, no matter how, 2, 4, 0, 9, 9, 0, 4,
It
2.
will be divisible by 3,
Yeah.
right?
So you have to make all the possible cases for that.
Yeah. Okay.
Okay. So
Alright.
similarly, here we did for 4, right?
Mhm.
We had 0. I think we have 2 also, right? 2, 0, 4, 5, and 9. Okay. So let me just write it in order. So it will be easy to 0, 2, 4, 5, and 9, right? So first I consider 0, 2. It's not divisible by 4, so it won't. So if my number ends with 0 and 0, 2, then the whole 4-digit number won't be divisible by 4, right? So I
No.
exclude this one. Then I
Hmm.
consider 0, 4. Similarly, 0, 5, and 0, 9 won't be divisible. Then I take 2, 0. 2, 0, yes. 2, 4, yes. 2, 5, and 2, 9 won't be, right? Then 4, 0, yes. 42, no. 45, 49, no. 50, no. 52. Like that, I made all these 6 cases. I think one is missing. Yeah, 92 also. So I selected if my number ends with any of these 6 pairs, then my whole 4-digit number will be divisible by 4. Okay.
Okay.
Let's move to the question now. So, okay. First case is my number ends with 0, 4, right? My two of the, let me just do it on whiteboard. Should be simple. Okay. Okay. See, first I am saying that 0, 4 is fixed at the last 2 digits, right? 0 and 4 has been consumed. So for the first 2 places, I have only 3 numbers to fill with, 2, 5, and 9, right? So any of the 3 can come here. Repetition is not allowed, so remaining 2 will come here. So there are 6 ways to form a number that ends with 0, 4, right?
How, sir?
I have fixed 0, 4 at the last 2 places. Okay, it is
This is
fixed.
fixed.
Then I have
Only
these three numbers
2
remaining.
is left.
So I
We have
can
to
use any of
choose
and
2.
I
2.
yeah.
The 3 C2, na?
No,
It will be
3P2.
3C2, na, sir?
Order matters. Order matters.
Okay, oh, yeah,
of
right.
permutation.
3P2. 3P2.
3P2. Yeah. 3P2 is same as 3 times 2, right?
Right.
So it's I got 6. Okay. Similarly, if my number ends with 20, again I have 6 ways, right? And if it's ends with 40, again I have 6 ways, right? Let's just move to another case. Okay. Suppose now my number ends with 24. Okay. Then I am left with 2 has been consumed, 4 has been consumed. I am left with 0, 5, and 9 only, right? For the first place, I cannot use this 0. Then it will be a 3-digit number, right? So I have only 2 options for my first place. One of these 2 is used here. For next, I have one of these 2 and 0. So again, 2 ways, right? So if my number ends with 2, 4, I have 4 ways to get my 4-digit number, which ends with 2, 4, right?
When 0
Similar,
is there, when 0 is
yeah.
not used, then it will be
Yeah, I
deducted.
cannot use 0 as first place, right? So I can use only these 2.
But
And
0 can be used in between, no, sir?
yeah, I used it. Suppose I used 5 here. Okay. 5 is cancelled. Then for next, I have again 2 options, 0 and 9. If I use 9 here, then I have 0 and 5 for the second, 2 options always, right? And for the first place also, I have 2 options. Is it clear or?
Got it, sir. So, how many divisibility rule do I have to remember? Like 0, 2, 3, 4. I got it. Apart from these,
5, if it's end with 0 or 5, it's pretty simple, right?
5 is 0 and 5. Yeah.
Yeah. For 6, it's if it's divisible by 2 and 3.
2 and 3. How will I check? Okay.
For
The
2, you
all
can
the numbers. Okay.
Yeah, but we
Okay.
won't give such complicated question. It will be okay. I will try it. Okay, we can do that. We will mention the divisibility rule along with the questions if it's the matter. We can do that.
Yeah. Please on that
Okay.
yes. Here he will assume that it is divisible by 4 if it is the last 4 digit numbers are divisible by 4.
Yeah. So see, if it's ends with 0, 4, I have 6 ways, right?
Yes, sir.
3 times 2. If it's end with 2, 0, again I have 6 ways. If it's end with 2, 4, I have only 4 ways. If it's end with 4, 0, again I have 6. Here 4 and 4. Adding them all, I got 12, 18, and 30 ways in total. Now I am adding it because all of these cannot happen simultaneously. Either my number will end with 0, 4, okay, or it will end with 2, 0. Both of these cannot happen simultaneously. So that's why I'm adding them.
What's
Okay.
that? Which one?
Either my number will end with 0, 4,
Yes, sir.
or it will end with 2, 0. It is not possible that at the same time my number will end with 0, 4 and 2, 0, right?
Yeah.
So either this will happen or this will happen, right? So that's why I'm adding all this.
Yeah. Case.
Okay.
These are the cases.
Yeah. Okay, so let's move to the solution. That's what written here. Okay. So I fixed 0, 4, then I have 3 remaining numbers to fill the first 2 digits, which can be done in 3P2 ways, right? Similarly, for 20 and 40, I have 3P2 in each case. If my number ends with 2, 4, then I am left with 0, 5, and 9 to fill the first 2 digits, of which 0 cannot be at first digit. So for first place, I have 2 ways, and for second also, I have 2P1 ways. So in total, 4 ways for each. And adding for all this case.
Sir, for 52, it is 4 ways, no, sir?
Yeah, 52 plus 4 ways. 52 and 92, 72 won't be here. Okay, so yeah, I added all these 6 and I got my answer as 30.
I do have a small question here.
Yeah.
Why are we choosing P and not C?
Because order matters.
Yeah, but when I'm choosing only one digit, it doesn't matter which order I'm choosing now.
Yeah,
Though in
so
that case, P and C is the same, but
yeah, both will be same. Yeah, but in general, if I increase it,
Mhm.
if I increase it, then order matters, right? So in general, I wrote P. It doesn't matter. You can also write simply 2 instead of writing P or C.
yeah, that is it. Now, 3P1 or 4P1, 3P1 or 3C1 will be same, no?
Uh, uh, yeah, it will be same.
Yeah, so
Yeah, all the same. Yeah.
In case of 3, it is okay.
Okay, let's move to our next question. I think. Consider the numbers again. The same thing. We have to find number which are not divisible by 4. Number of how many numbers can you form 4-digit without repetition? Let's just work on this.
in this case, we have to figure out numbers which are divisible by 4, then minus, right? All the numbers then.
Yeah, you can do that. Total and minus that. Yeah. 3 minutes will be enough, I think. Already discussed the answer.
Two zero is included, no? Numbers that are divisible by 4. The last
Yeah,
two
20 is also divisible by 4, so it's included. Yeah.
0 4 2 0 2 4 5 2 9 2. Right.
Yeah, there were 6 as far as I remember. Okay, So let's. You guys need more time, or shall we move to solution?
It's a solution.
Okay, let me see your responses. Yeah, majority of you got it right. 66. Yeah. Okay, so yeah, total numbers we formed are 96, and of those divisible by 4 are 30. So we are left with 66 number which are not divisible by 4. Okay, let's move to the second question. Okay, so we are selecting the World Cup squad, which is consist of only
Okay.
4.
Sir,
Yeah.
please just
So can you please show the solution?
Yeah.
One
how,
second.
how to 96, sir?
In see, here, how many 4-digit number can be formed? 196, right? So total number we can form are 96. Of those which are divisible by 4 are only 30. So remaining ones are not divisible by 4. Right? So it's 96 minus 30, 66.
Okay, sir.
Okay, so next, yeah, so you have to select the World Cup squad, which consists of 4 players, and you have 10 options.
Can we please, sir, can we please go back to that answer?
This one?
Yeah, because it is derived from the other two questions, no?
Yeah, that's what
When-
it's mentioned, right?
No.
Whenever it's mentioned prelude to, it means this will be used in question 1.
Yeah, what I'm telling, if suppose it is from ground zero, if you want to prepare, how do
Yeah,
we do that one?
yeah, I will do the same steps. I will first find total number and then
So you
find
reserve the
divisible
same
and
four
then-
numbers, no? 0, 4, 20, 24, and 40. You reserve it for the last 2 digits, no?
Yeah, and then I will subtract it because it will be easy rather than counting all those cases which are not divisible by 4.
I tried that way. I'm not able to reach out. That's why.
Now you can do it that way also. You just have to make all the possible cases. Let's just quickly do
See,
it.
first we reserve 20,
Uh,
0, 0, 4, 20, 24, and 40.
okay.
And 52.
52. Oh,
One
that's
more
another
case
one,
was
huh?
there. One
92
more is
also.
there.
And
92.
92.
92. Yeah, 6 cases were there.
This one is okay. So,
So
that
yeah.
means, so okay, now each one is a case, no?
Yeah, if you want to do it direct, like not divisible by 4, then you have to make all the options which are not. You can take 02 as a case, 05. But it will be very lengthy, right? Too many cases.
Yeah, we
Okay.
don't
But
need
I
to do
can
that.
do this.
All non-divisible numbers will be okay.
Yeah, so but yeah, so easiest way is I can find total number and just subtract for these 6 rather than doing this tedious calculation.
Oh, okay. So you better do that way, yeah?
Yeah, that's the better way.
So without any constraint, you take the total numbers, and divisible by 4 case, you take a separate number, then subtract it.
Yeah,
That's the method. Okay.
but that's just an easy way. You can do it that way also, but it will be a bit calculated.
Okay.
Okay, so let's just start this question quickly. So yeah, you have to select 4 players from a group of 10 players. And there is one condition that X and Y, two players are there who will either be selected together or both will not be selected. So condition is something like that. So you have to find the first case. If both X and Y are included in the squad, then in how many ways can you select the World Cup squad? Okay, let's just move to solution. Okay, most of you have answered it. Close to 100. Oh, okay, this should know that. So just go for that.
It will be 8C2, na sir?
Yeah, it will be 8C2. Two places are already filled by X and Y, and X and Y are already included. So you are left with only 8 people and you have to select 2. So 8C2 base, which is 7 times 2, which is 28 base, is the correct answer.
Sir, why it is combination and not permutation?
Because order don't matter, right? Suppose I select players A, B, X, Y, and I select player B, A, X, Y. My World Cup squad is same for both of these, right? So
Yes,
when
sir.
order is not important, we use combination.
Okay,
Because
sir.
either I select A first or B first, they both are the same.
Okay, sir.
Okay, let's do
If we,
this. Yeah.
sir, if we say that x y is fixed, then we have the three places.
No, 2 places. Because only 4 players are to be selected. It's mentioned here.
4 players are required to be selected.
Yeah.
X and Y is already fixed. Then you make a single.
Then you have left. No, why it's single? You are selecting 2 players already. No? Both X and Y are included.
Yeah. No,
So we are
I'm
left
telling
with
that I'm
yeah.
telling that X and Y is already selected.
Yeah.
Right? Then it can be taken as 1. Then only 2 is required. Right?
Yeah.
Then the 2 can be selected out of 8.
Yeah.
It's right.
Okay.
What is the answer? It's not clear. Something superimposed there.
Yeah, it's actually I don't know why it's happened, but yeah, it's written as X and Y are already selected, right?
10
Yeah,
minus
then
2.
it's 8C2.
10 minus your option remaining 10 minus 2, and you have to select 4 minus 2
Yeah,
because
that is
2 are already
8C2 thing.
yeah, 8C2, which is 28.
Yeah.
Okay.
Then not selected case,
That's the next question, I think.
you are not considered that one?
Yeah, not the question is both are included in the squad, right?
No, but here in left side it is okay. This is the case, and this is a question here, huh?
Yeah, that's prelude. Yeah. So next one is the one you are saying. Oh, if X is not included in the squad, you have to do that. Okay, let's just quickly.
$70.
Excuse me, sir.
Yeah.
So I had a question. When will we be provided solutions regarding the quiz 1 or qualifier 1? Like solutions explaining.
Okay, we will release it in a few days. We will do that.
Sir, can we have a session regarding it? Because the quiz 2 is approaching as well, and that includes week 1.
For quiz 2, also you will have a revision session like you had for quiz 1, right? So there, everything will be discussed, and you can also ask any doubt from week 1 to 6.
Okay, but the solution explaining will be released, right?
Yeah, it will be released. Yeah.
So the quiz 1 results, when will it come?
I think results will be out anytime. The results have been prepared. It's just to be announced.
They will be announcing on or before Thursday.
I think you, but I think that's the admin part. Only they can.
Yeah,
tell.
sir. I asked to support. They said they will announce it by Thursday or before it.
Yeah, so they will do that. Yeah, because it's prepared. You just have to release it. So it will be released either tomorrow or today. It can be like that also. Yeah, quiz 2 will be from week 1 to 6, not 1 to 8. Okay, let's see the responses. Most of you got 70. See around it. Let's see the answer. Okay, so yeah, the here question was that X is not selected in the square. But from the question, we know that if X is not selected, then Y will also be not selected. So again, we have to choose the 4 players out of the remaining 8, which can be done in 8C4 ways, which is 70. I think it's clear. We can move to next one, right?
Such type of explanations in the activity questions are also required, sir. Because answers are there, but most
Yeah,
of the things are
activity questions are mostly based on the videos.
theoretical.
Activity questions are purely based on the lectures of Usha ma'am. So we expect you to do that by just watching the videos, and solutions are within the video itself. Okay, so I think it's clear. We can move forward, right?
Sir, can anyone tell the formula once again for combination? I made a mistake.
Okay. Okay, so here it's given that X is not selected. Okay. No, not selected. And if in the question it was mentioned if X is not selected, then Y is also not selected, right? So we are left with 8 people, and we have to select 4 for the World Cup squad. Okay.
Right, okay.
And it can be done in 8C4 ways. Okay. Because order doesn't matter. If I select A, B, C, D, or I select D, A, B, C, my World Cup squad is same, right? So order don't matter. So I use combination. You can also write it as 8C4. So whenever you see something like that, it's same. Okay. Okay, so it just means you have to open it 4 times. Okay. The formula is n factorial, r factorial, n minus r factorial. Here our n is 8 and r is 4. So it's 8 factorial by 4 factorial, 8 minus 4 factorial. 8 I can write this as 8 times 7 times 6 times 5 times 4 factorial, right? 4 factorial and 4 factorial. 1 gets cancelled out. So it's 8 times 7 times 6. 4 factorial, I can open it as 4, 3, 2, 1. And you can do the calculation 3, 2, 6, 2, 70, right?
Okay. Isn't there any general way without using the formula to do this, sir? Actually,
one thing you can do it is if it's written 8C4, just open 8 factorial 4 times 7. Okay, 4 times and divided by 4 factorial. For 8C2, just open it 2 times and divide it by 2 factorial.
250. Okay.
That's simple. Because that thing always cancels.
Yes, sir. I actually did only 4. I didn't use that factorial.
Okay.
Thank you, sir.
Let's move to next one. Yeah, so here in how many ways can the squared be selected? That's the main question you have to answer. Okay, let's move to solution, I think. So 98 and okay, let's see. So yeah, there are two cases. Case one is that both X and Y are selected, and another one is both are not selected, and these were the only two possible cases. So adding them up, we got 98, which is the correct answer. Okay. I think we can move forward. Any doubt in this? Okay.
Shall you explain the solution, sir?
Yeah, there are only two possible cases. Either both X and Y will be selected in the squared, or both will not be selected in the squared, right? So if both are selected in the squared, we calculated earlier that it can be done in 28 ways. If both X and Y are included in the squared, it can be done in 28 ways. If both are not included in the squared, it can be done in 70 ways. And For adding these two cases, we got 98 because these two are the only possibilities. No other conditions on this selecting of squared, right?
Okay, sir. Thanks.
Let's move to another question. Okay, so we have three distinct awards, say flower bouquet, chocolates, and toys. And there are 6 students, say A, B, C, D, and F. And there is condition that chocolate can be given either to A or F, and toys can be given to either of A, C, or F. And if suppose if I am giving something to B, like if I am giving toys to B, I cannot give the toys to any other student. That's also a condition. One award can be given to only one student.
Sir, I have a doubt in this question.
Yeah.
Like, it is said that chocolates can be given to either A or F, and toys can be given to A, C, or F.
Yeah.
Okay. So if chocolate is given to A and a toy is given to C, then would F be given?
Yeah, flower bouquet can be given to any of these. There is no condition on it.
Okay. Okay. Thank you.
I have another doubt, but should I
Yeah.
ask you after the solution or before?
Yeah, just ask.
If chocolates can be given 2A or F, then it is 2C1, twice is 3C1, and rest is 4C1. But do I have to multiply these or add these?
If you are doing this simultaneously, right, then you have to multiply.
Simultaneously, I didn't get you.
Like, it's not like if you have given, say, chocolates to A and toys to C, then it is not that you can't give flower bouquet to any other students, right? You can do all of these three simultaneously. You are giving something to A,
Okay,
then
okay,
B
okay,
gets something
okay.
to B. In that case, you have to multiply.
Got it. Got it. Okay. But then there will be another problem. Chocolates I can give to A because I have 2C1, I'm taking it, and toys, then I have to do 2C1. Okay. Because A and F exist both.
Yeah, that's what you have to think about. Make cases is the only game here.
All right, okay.
Can ACF also take like a bouquet?
Yeah, bouquet can be given to any of these 6. There is no condition on bouquet, right?
Okay.
So B, D, and E, they do not have any condition. They can take all the 3. Either one of the 3, they can take it as a reward, is it?
No, there is not condition on the sugars. There is condition on, say, awards. Like chocolates can either go to A or F, not to B, C, D, or E.
No. Just hold on a minute. So chocolates can go to A or F. Means what?
Means I can give chocolates to either the.
Bouquet and flower. Flower, bouquet, and toys cannot go to them.
No, they can also go to them, but chocolates will go to A or
Just
F.
1 minute. So now toys cannot go to B, D, and E.
Yeah.
Is that right?
Yeah.
So B, D, and E will not get toys ever.
Yeah.
So only 2 choices for B, D, and E. A gets 3 choices. Anything they can take it, is it?
Yeah, you can say that.
It will consider last one. Hello.
Yeah.
If I correct my answer, then it will take last one.
Yeah, it will take the last value you answer.
So that condition that if toy A are given to A, then it cannot be given to any other student. Will it be applicable for flowers bucket? Hello.
Okay, let's move to the solution. Let me check your responses first. Okay, most of you have answered 16. Okay. So yeah, 16 is the correct answer because chocolates can be given to either A or F. So you have two options to give chocolates. Then in terms of toys, we have again two options because either of A or F have already received the chocolates, and so he can't be given twice. So you have two options again for toys, and flower bouquet you have can be go to any of the remaining four ones. So total number of ways is 16. Like 2 times 2 times 4. Any doubt in this, or shall we proceed?
Sir, shall you tell how these two came here? These two for it means it two is denoting a person or either it denoting to a award.
Wait. Two is okay. So you have 6 students, right? A, B, C, D,
Yes,
E,
sir.
and F, right? This is the colors. Okay. So first you have chocolate. Chocolate can go to either A or C, right?
Or C.
So I have 2 ways to distribute chocolate, right?
Yes, sir.
Next you have toys. Toys can either go to A or C
or C
or F.
or F.
But A or C, one of them has already received the chocolates, right? So I cannot give toys to them. So one of these is eliminated. Okay? So I am again left with 2 options.
Yes, sir.
Okay, next last is flower bouquet. It can
Yes,
go
sir.
to any of the remaining 4 students.
Okay, remaining 4. Yes, sir. 2 into 2 into 4. Yes.
That's a 6.
Thank you, sir.
Okay. Yeah. So, okay, let's move forward. Question number 4. Okay, for a card game, there are 5 seniors and 4 juniors, which are to be seated on 9 chairs at a round table. Then, in how many ways you can place them such that 4 juniors are always sitting next to each other?
So in the previous question, you told that if A and F will be eliminated, so will the
Yeah.
2 toys will go to C?
C or either of A or F, because one of A and F has received the chocolates, right? So he cannot receive twice.
Oh, so 2 is and then F.
Yeah.
Okay, sir. Okay.
Hello.
Yes, and please say.
Sir, I have to go to pd.com and write that X.
Yeah, join pd.com and the code on the right top of the screen.
Yes, sir.
Let's increase the timer for 1 minute, I think. Few of you are still doing it. Okay, let's just move to solution. Check your responses. Okay, 144, majority 2520. Someone is answering 47. Okay, so here number of seniors are 5, the juniors are 4, and I know that 4 juniors are to be placed next to each other, so I consider them as just one single unit. So in total, I have 5 seniors and the group of juniors, so in total 6. So I have to place them in round table, which can be done in 5 factorial ways, and the juniors also can be arranged in between in 4 factorial ways. So the answer will be 5 factorial times 4 factorial, which is 2 weighted C1.
We are multiplying just because it is occurring simultaneously, right, sir?
Yeah.
Okay.
If they are not sitting in a round circle, if they are sitting in a linear way, what would be the difference?
It should be 6 into 4, sir.
Then it will be 6 factorial into 4 factorial. Yeah.
So that time it is 6 factorial into 4 factorial. Why 6? Why 6? This is the 5 and 4.
Okay. So you have 5 seniors, okay? S1, S2, S3, S4, and S5, and 4 juniors, right? J1, J2, J3, J4. I consider this
One
as
unit.
one single unit, just J. Okay, so in total I have 6. Okay, so if I am arranging them in linearly, okay, so then it can be done in 6 factorial ways. Multiplied.
This one has also was a 1 unit. Huh?
Yeah.
One contiguous unit with that. Okay.
Yeah. Also, I can arrange inside it. I can arrange in 4 factorial ways, right?
But how does it changes when you put it in a circle?
Because there we have no starting and end point. Okay, let me. Suppose you have only 3 people. Okay, A, B. Or let's take, okay, let's take it 3. Okay. 1, 2, 3. Okay, so sorry, 3 only. Okay. So if I am writing A, B, C, I am starting from here. Okay. Is someone starting from this point? A, B, C. Someone starting from this point. A, B, C. All these 3 are the same because in circle we don't have start and end point like in the linear line, right? It's
But
also
still,
same.
B and A can be interchanged. Instead of considering second and third, within the first arrangement itself, B, A interchange.
Yeah, that will happen. But if I'm saying A, B, C, then I can arrange them in this order: A here, B here, C here. I can arrange A, B, C like that. I can also arrange A, B. So all these 3 are the same, right?
But yes,
all these.
say, for example, within the same arrangement, rather than looking at different, because we are looking at combinations, permutation. So A, B, C is the one. Let's say B, A, C, B, C, A like that. It will come as 3 factorial, right? Taking like within the first arrangement itself. Can you draw a circle?
Yeah. Okay.
And ABC, any of the ABCs.
Okay, let's just do that. A, B, C. Okay.
So let's interchange. This is the first arrangement, number 1. Second one, let's interchange B and A. Just B and A. See, let's see B assets.
Yeah, that's different, right?
This is the second one, right?
Yeah, that's second one.
And the third one is AC interchange.
Yeah, you can do that also in this strategy, right? C, B.
CA and the other interchange is between first thing is A and B. Interchanged.
This is
B
same as this one. You can see that.
Yeah, but we have to look into this one, right?
This circle is same as this one, right?
ACB.
ACB, ACB.
Yeah, but we are looking at the arrangement also, right? Not just the people that are, no?
Yeah, but how can you say that these 2 are different? It's just like, because in circle we don't have starting and ending point. It's not like I'm starting from here only. Like in the line, I start from here, I end here.
Yeah,
in
I got it. But
it's not like that.
If you're looking at the car players playing cars, probably we can see that B is to the right of A in case of first arrangement.
Yeah, in circle.
But here it is left. Yeah.
Yeah, it's
Sir.
Yeah.
Sir, I want to ask question here. The anti-clockwise, clockwise is matter or not?
It don't matter in here.
Sir, how we identify, sir, whenever the clockwise or anti-clockwise matters or not matter?
That's the different kind of question. You will get, you will get some kind of question like that. Okay, but let's do that here. Okay, let's consider 2 people only. Okay, A and B. I got A here. I got B here. I got B here. So these 2 are both the same, right?
Yes. This is same.
Yeah, this is same. So here, if I have to arrange them in linearly 2 places, then it can be done in 2 factorial ways. But in circle, there is only one way to arrange them, right? 2 factorial by 2.
That's the factorial n minus 1 ways in the circle.
Yeah, which is just same as n minus 1 factorial.
I still didn't understand in circle how arrangement. What does exactly arrangement mean? This is because here we have A to the left and B to the right. It could be treated as different from B, you know.
No, it's not different. Here, see, still A is in front of B, right? A is still in front of B. So how can you say that these 2 are the different things? Because it's not the starting point, right? And because someone can place A here, B here, or someone place A here. Both are still the same cases, right? Both are still sitting face to face to each
If
other.
you consider 3, so let's consider 3 so that it can be.
Yeah, let's consider 3. Okay. Yeah. A, B, C. Okay, and someone could place A here, then B here, then C here. Okay. Okay. Another way is I can start from here, A, B, and C. Another way is start from here. C.
But
These all
but
three
we
these
don't
are
need
same.
to. But we don't need to be in the same order A, B, C. No, could be A, C, B. There is another jumbling possibilities there.
You're saying A, C, B. Yeah, that's different because here C
That
comes
is
in between A and B.
that is why we are considering permutation of that, right, sir?
Yeah. So if you see when we have three people, three cases are same, right? So that's why we always divide it by 3, like 3 factorial by 3, this 2 factorial. So when you have n people, linearly you can arrange them in n factorial base. But in circle for each of the case, n of those are same. So that's why we divided by n, which comes out to be n minus factorial in case of circle.
Okay, in case of circle, n will be n minus 1. N people arranged will result in n minus 1 factorial base.
Yeah.
Whereas it will be n factorial in case of
Linear.
linear arrangement.
Yeah.
Okay.
So the difference between circular and linear is n, is it?
A ratio of them, I think, not difference.
Or the ratio. Okay, the ratio is n.
Okay.
Excuse me, sir.
Yeah.
Sir, in this case, why can't we consider that both are the same, like clockwise and anti-clockwise are the same?
Can you repeat this? Let me open that.
Like, if it is the same, we take n minus 1 by 2, right? Factorial.
N factorial by n, yeah.
No, like if both clockwise and anti-clockwise, we can take n minus 1 factorial by 2, right?
Yeah, if it happens, if yeah, okay, I got the question you are referring. Suppose there is a necklace, okay? So the necklace, I have to enter place beads in it, okay?
Yeah.
If all the beads are of same kind, so it doesn't matter if I move clockwise or anti-clockwise. In that case, we divide it by 2. That's completely different question. So you are referring.
Okay, so in this case, like it does make a difference.
Yeah.
Okay.
These are the distinct objects, and that is the same object, right, sir?
Yeah.
So one more question.
Yeah.
The 4 juniors can interchange their position in 4 factorial ways, but they are also sitting around a circle. So ABCD and CBAD will also be same.
No. Me just. Okay. This question I was expecting. Okay, suppose there are 1, 2, 3, 4, 5, 6 places. Okay, let's consider 1, S2, S3, S4, S5, and all the 4 juniors sitting here. So it's kind of a linear thing, right? Not circle. Because 4 juniors are just here. They are not completing a circle around it. 1, 2, 3, 4. You can change them, right? Here A, B, C, D is different as B, A, C, D, like that. So when we are interchanging in within this, we have it's linear, not circular.
Sir, but here also is senior are 5, then also we are taking 5 factorial. Isn't it in a linear way?
Oh no, we have total 6. Let me just do that.
So if all the 4 juniors are included, then how does it matter if in which order they are seated?
It will change the way, right? Suppose let me just do it. Okay. 2, 3.
Oh yeah, it's a permutation. Got it.
Okay. S1, S2, S3, S4, S5. Okay. Now consider these 4. These four are kind of a linear. They don't complete a circle, right?
Yes.
So here it matters if you place A, B, C, D here, or if you place D, B, C, A here, right? because here A is beside of S1 or here D. So these two are different cases, right? And also, so consider these as a linear. They don't
Now
complete a
got it.
circle. Okay.
Okay, sir. Thank you.
Seniors are 5 or 6, sir.
5 seniors, and I have considered 4 junior as one single J capital. Okay.
So we are
5.
also arranging the senior into in a linear way only now, because 5 factorial.
No. I am not arranging seniors in that way. I am arranging these 6 entities: S1, S2, S3, S4, S5, and J.
Okay.
I am this J contains 4 entities. Okay, so first I am arranging these 6 in the
Here,
circular
clockwise
way.
and anti-clockwise are different, right?
Yeah. Here I am arranging these 6 in 5 factorial way, and within this J, I can arrange them in 4 factorial, because this is a linear combination.
Sir, it is it not possible that the cases when the juniors are seated in 3 and 4 and 4 and 5 and 2 and 3 and S1 and S2, then cases are same. Suppose
Yeah, that
J2 is sitting with J2 is sitting with S2 in the left of S2, suppose.
Yeah, that's why we did 4 factorial for that.
No, 4 is there, sir. But why it is required to take the 5 factorial? Because we are taking permutation of the 4 juniors, then they can sit in between. There are 5 places. They can sit in between with the permutations.
Yes, sir. They can sit in between seniors.
Yes. Then why
Yeah,
it is required
all
to
these
take?
cases. See, when I'm arranging it in the circular manner. Okay, so I am considering all the cases: S1 here, J here, S2 here, or S3 here, S4 here, J here.
Got it, sir. Got it, sir. But how can we sure that J in between S2 and S3 will not coincide with the S5 and S2? Suppose J1 is in the left of J3. Suppose
one moment.
Yeah.
Okay. J1 is in the left of J3. Okay.
No. J3, okay, no problem. J1 is in the left of S3.
Oh, okay. J1 is in the left of S3. Okay. Then remaining 3 juniors.
Yeah, whatever it is, no problem.
Yeah.
In the next arrangement, when S1 is in between S1 and S3, suppose it is S1 and S3. In the next arrangement, the juniors are between S3 and S6, S4 or S5. S3 and S5.
Okay. S5 and S3.
No. Keep this one, sir. S1 and S3. It is a one case.
Okay. Okay.
Because I'm not being sure that whether this J1, J1 is in the now here. J1 is in the left of S3.
Okay.
And now let us see. Yeah. Now let us see juniors in between J2 and J3. Just write J2, S2.
Yeah.
S2 and S3, and in between, and now J1. No, sir. Sitting will be there, na. It will be adjoining, na, sir. S2 and S3. Arrangement is S2, S3, S5. Suppose there is one arrangement. S2, S3,
In
and
this,
S5.
in continuation of this, you are saying, right? S2, right?
Yeah.
Okay. S2 is here. Okay.
S2, S3, S5. There are two spaces between S2 and S3, and S3 and S5.
Okay.
Now consider J1 is on the left of S3 and on the right of S3. There are two cases will be there, no, sir?
Yeah, these two cases are already different, right? If I am considering them as J, then it's S1, J, S3, right?
Okay.
And in that case, it's S3, J, and S5. And that's why I can arrange them in, it's possible that J2 is here, J3 is here, J4 is here. That's why I multiplied all the possible arrangement of this J with S5 by 4 factorial. Either J1, J2, J3, J4, all can be here.
So we have to presume that these arrangements will show that no arrangement is coinciding with each other.
Yeah,
Because
they will not
we
coincide.
cannot see here, I think.
No, you can try it for the smaller
Physically,
values.
we cannot see. That's why I'm saying.
Yeah. But you can, if you want, you can just try it for smaller values also. It will clear it. Okay,
let us take two juniors and 3 seniors.
Okay, let's take 2 juniors and 2 seniors. Okay, that will be.
So that in between we can see.
Okay. So, okay, let me take 2 junior and 2 seniors. Okay. That will
So, 3 seniors, huh? Then
3 seniors.
So that we can permute, na?
Okay. No, we can do it for 2 also. Okay, let's just start with 2. If we require, we will move to 3.
Yeah.
Okay.
Now 2 juniors.
Okay, see.
No, sir. S1, S2, S3, and J1, J2.
No, first start with just
Okay.
2 seniors and 2 juniors, which are in J, placed to be together. Okay. So if I place J here or J here, it doesn't matter. They both are same, right? J is in between S1 and S2.
Yes, sir.
So total number of places is 1 here, right?
Yes.
Now let's open it. Okay. One. Let me just. I will do it in this circle. Okay. Okay. So first is S1 is here, S2 is here, right?
Yes.
One way is J1 sits here, J2 sits here. S1, S2, J2 sits here, J1 sits here, right? These are different cases.
Yeah, 2 cases.
Yeah. So in total we have 2 ways, right?
Factorial 2, yes.
Yeah. So that's what we did, right? For 3 we have 3 we have okay. We are arranging them. 1 minute. S1, S2, J. Okay, so there is another possibility is this one, right?
S3.
S2J. There are 3. Just 1 minute. Let me do it.
Okay, sir. Not right.
We can replace. Okay, let's just do it with first A, B, C. A, B, C. Okay. Let me just replace A and C. C and B. So that's another possibility. CAB. Okay, I don't think there is any other possibility, right? Okay, so let's just take it as S1, J, S2. This was where J, this was where S1, this was where S2. Okay, so there are 2 ways in total to arrange these 3. And within J, you can do it like J1, J2 or J2, J1, which also gives you 2 cases. And here also it gives you 2 cases. So in total, you will be having 4 cases, 2 from each, right?
In other cases also like
yeah,
permuted. In between they will be permuted, and juniors will also be permuted. The places of the seniors will also be permuted among themselves, right?
Yeah.
Okay, sir. Got it. Got it.
Let's
Thank you. Thank you, sir.
move to the last question. Just find the value of n. I think that's pretty simple.
Sir, I have a doubt in general. Can I ask?
Yeah, please ask.
Sir, I have not selected statistics for the upcoming sessions. So should I submit the assignments of statistics also?
Which week? Like week 5 and 6?
Yes, sir.
If you can solve it without watching the videos, I think you should.
I have opted 3 subjects for the qualifier after the qualifier. So
Okay.
should I?
Yeah, you can.
Okay, sir. Then they will be marked for assessment also, or they will not be counted.
If you are taking statistics as a subject after it, right?
No, sir. I have taken 3 subjects.
Not statistics, right?
Yes, sir.
So you will have to do it in next term. I don't think you will be able to do it this term.
Okay, sir. Yeah. So I should not do it now.
Yeah, I think in the next term it will open. For more details, you can like mail to support team. They can tell you better.
Hello, sir. Can I ask a question?
Yeah, please ask.
So I had to leave this meeting to join another call. So I missed the discussion on the last question. In case you've answered it, the question I will watch it on YouTube. But in case you've not answered, I have no idea. So I'm asking this. In the last question, I had done the calculation as 6 factorial into 4 factorial. So how does the 6 factorial? It was counted as 5 factorial.
Because when we do it in circular arrangement, it
Mhm.
becomes n-1 factorial and not n
Okay,
factorial.
okay.
That's what I have shown by taking example of 2 and 3 students like that.
All right. Thank you so much, sir.
Okay, I think most of you are still doing it. Let's just take the last timer. Then we will proceed.
Mr. Ishan, I want to see the solution for question 21, if possible to go back.
21?
Yeah, like 2 questions before, chocolate, toys, and bouquet.
Okay. After this, we will go back to the question.
Yeah, please.
Okay, let's move to the solution for now. More than enough time. Most of you have answered 3. Okay, one has answered 5,000 also. Okay, so I've just put in the values of first NP3 and in denominator n plus 1 P2, which is equal to half given to me. Then on cross multiplying, I have got this equation. Now solving this, we will get 2 values, n equal to 3 and half. So it is given that n is a natural number, so I've taken n equal to 3 as my answer.
Sir, how did you get that the above?
Which thing? This first equation.
Yes.
Okay. Okay, so it was given as a question. Let me see. Okay. Okay, so it was NP3 and n plus 1 P2. Okay, so given NP3 divided by n plus 1 P2 is equals to 1 by 2, right? So NP3 is n factorial divided by n minus 3 factorial, right? Which is same as n minus 1, n minus 2 plus 3 factorial divided by 3 factorial, right? This get cancelled out. So my numerator is n times n minus 1 times n minus 2. Okay. Denominator similarly is n plus 1 times n. just 1/2, n gets cancelled. 2 goes here and this goes here, so it's twice of n square minus 3n plus 2 is equals to n plus 1, right? 2n square minus 7n plus 4 minus 1 plus 3 equal to 0, and then you can do it, I think. Minus 6n minus n plus 3 equal to 0. 2n common and minus 3 minus common minus 3. 2n minus 1 and minus 3. So, n equal to 3 comma 1, right?
Yes.
So n is a natural number, so 3 is the answer.
Yeah. Four we
So
check,
this is not doubt.
and others.
Sorry.
One. Yeah, please ask.
In that 4 also, one request,
these
one
instructions
line item is
solve
that
the association.
it
One
specify
by one,
all
please.
type of requests.
One
So
by one.
we checked only
Yes, sir.
new and
So
change
this,
user,
these
but lock unlock is
instructions,
not
all
yet
the
checked.
instructions will be available on
And
YouTube
one,
later also, sir.
and
1 minute. Yeah, just ask one by one. I think there is an echo from. Yeah, please ask now. Let's just move to the slides first. Okay, so any doubts in the slides for now?
No, sir.
These slides will be uploaded.
Yeah, it will be uploaded. All the slides are uploaded.
Okay.
Okay. The solve within chapter. Yeah, it is also available on YouTube.
21, please.
Oh yeah, 1 minute.
Was that a last question, sir, or is there any more?
yeah.
Sir, uploaded means I didn't get that. These are uploaded.
Oh, 1 minute. Okay. Which one that we need to share my screen? Okay, point. Which question we're referring? I think someone was
The
referring
chocolate
to.
and toy one. Yeah, this one.
Okay.
Just I want to
Okay.
see solution.
Okay, so chocolates can give back to either A or F, right? Two sugars.
Yeah.
Then one of them has already received the chocolate, so he cannot receive twice, right?
Right.
So for twice, we have option C or one of them available who has
Yeah.
not received the chocolate. So 2 option again.
Yeah.
And flower bouquet can go to the remaining 4, right?
Right.
So 2 times 2 times 4 is 16.
Okay.
Sir, for these kind of questions, how should we approach it? If you could have approached from the flower bouquet.
Okay, yeah, you can do it as well. Okay, let's do it. Okay.
Like I was approaching from ABCD side, like A can have this many option, B can have this many option.
No, you cannot approach like that because everyone is not receiving everything.
Right. Like B can receive only bouquet. They cannot receive chocolate or twice.
Yeah, but all the 6 students also not receiving anything. Only
Right.
3 are receiving. So that's also a case here.
Okay. Thank you so much. Thank you.
Yeah. Any doubt in this last question or shall I erase it?
It's okay.
No doubt.
Okay.
Sir.
Okay, so A, B, C. Okay, so if let's suppose chocolate can go to AC and twice can go to AC, AF, right? Okay, so let's proceed from twice. Okay, here you have to make 3 cases. Case 1, that twice are given to A. Okay, then chocolate can be given only to F. For chocolate, we have only 1 case. For flower, we have 4 cases, right? So in total, 4 cases. Second case, twice are given to C. In that case, chocolate can be given to either A or F. And for flower, again, we have 4, right? So 2 times 4, which is 8. Case 3, twice are given to F. So again, chocolate can be given to only one, that is A. And flower for again we have 4. So again 4 cases. So adding this 4 plus 4 plus 8 again 16 in total. So you can approach it that way also.
So that is, it is more complicated.
Yeah, like straightforward, simple approach was first giving chocolates and then toys and then that. But you can also do it either way. You will get the same answer. Here you have to make all the cases.
In problems with multiple cases, no, we have a little bit lack of clarity on when to add or when to multiply it.
When to add and when to multiply. Okay, then you have to multiply when things are happening simultaneously. Okay, like consider first case only. Okay, I am giving twice to A, which can be done in one way. Simultaneously, I am giving chocolate to someone, which can be done in one way, right? And again, I am simultaneously given flower to someone, which can be done in 4 ways. So all these 3 events are happening at, you can say, the same time, you can say, or happening simultaneously. So that's why I'm multiplying it. 1 times 1 times 4. Okay. But see, if twice are given to A, and then I'm saying twice are given to C, these 2 things cannot happen simultaneously, right? Either this will happen or this will happen.
No, it is given A or C, no? The toys can be given to A or C.
Yeah, but it's also mentioned that that 1 hour, if twice are given to A, that it cannot be given to any other student.
No, the toys are, where is it? Toys. No, where is the condition? If toy.
No, it's written here in the question.
The
Note
question.
1. If twice are
It
given
says
to
that
A.
you can give to A or C, no?
Yeah, so if you have given to A, then you cannot give it to C, right? Because
That is the way
then
to read, or either you can give to A or to B.
yeah,
C.
you cannot give at the same time to both. Those 2 events are not happening simultaneously, right? These 2 cannot happen simultaneously. That's why I added.
But when you say A or C or F, means that we can give to only one guy.
No, here I mentioned it in the note. See, if twice are given to A, then it cannot be given to any other student. 1 award can be given. It's mentioned in the question here.
Is it mentioned in the question that every student will get a award?
No, it is not mentioned, right?
Not no.
No.
Only every. But here every student is getting at least 1 award.
Yeah, but this condition is not mentioned here. In the question, yeah.
This condition is extended to chocolates also?
Yeah, it's written now 1 award can be given to only 1 student. Awards are my flower, bouquet, chocolate, and toys. So it's possible for all 3. It's just an example. That is, if toys are that, it cannot be.
These statements restricts simultaneous activities.
Yeah.
So the cases need to be added up.
Yeah, you have to check these conditions, whatever given in the question. If this condition changes, the solution will change.
So how do we make this into a multiplication problem? Take out the condition, then it will become multiplication.
Okay. Let's do that. Okay. Okay, let's do it for okay. F. Okay, and let's say there is no condition. 1 award can be given to any number of students. Okay.
Yeah.
And I know chocolate are given to A and C, and flower can be given to A, C, and F, right? So there also you have to make the cases. Let's consider just one case. Okay, so see, A can receive all the 3, right?
Yeah.
Either flower, bouquet, chocolate. B can only receive flower, bouquet.
Yeah.
C can receive all the 3.
Yeah.
D can receive only flower, bouquet. E also. F can receive either flower. Oh, sorry, that's twice. Either flower, bouquet, or twice. Yeah. So that's your getting.
Okay, this is the case.
Yeah, things are happening simultaneously, right?
But here all the students are getting at least 1, sir.
Yeah, that's he asked me for a question when simultaneously things happening. So that's why.
Yeah. Sir, prelude 1 of question 1, I think.
Prelude one of question one, divisible by 4. Oh no, it's this one.
Yeah. Prelude one.
How many 4-digit number can be formed? Yeah, you just have to take any of these 5 can be except 0, like 2, 4, 5, and 9 can be at the first place. And so there are 4 ways to fill the first place. For second, again, you have 4 places because 1 is used at the first place, but you can use 0 here as well. For second and third, or for third and fourth, you have 3 and 2 ways respectively.
Okay, multiply, right.
Okay. Any other doubt or shall we?
So can I ask a question from activity question 6.4?
Okay, 1 minute. So let me share that. Okay, yeah. Which one?
Activities question 6.4, the first question.
Okay.
So in this question, out of 6 consonants and 4 vowels, how many words of 3 consonants and 2 vowels can be formed? So for the 6 vowels, I took 6p3, and for the for the consonants, I took it as 6p3, and for the vowels, I took it as 4p2. Is there something else that has to be multiplied that I'm missing? Because I got the answer 1440, but the actual answer is 14400.
Yeah, you have
Or
to
my
arrange.
approach is wrong.
You have to arrange them also, right? These
Okay.
5 can be arranged in 5 factorial ways also.
5 fact. Okay.
Okay.
Okay. All right. So 5 factorial will be 120. So 1440 into 120 will still not give me 14400.
Okay, let's do that. Okay, let me do that. Okay. 1 minute.
Or should I be choosing it instead of, using
Yeah, you have
combination
to
instead of
choose this.
combination? So if I use combination for 4 of them and then use for multiplied by 5 factorial, I think I should get the answer then.
First, that's what I was. Yes, there are 6 consonant. Okay. And 4 vowels. You have to use only 3 consonant and 2 vowels, right?
Right.
First, we choose 3 consonant, 2 vowels, then we arrange them, which can be done in 5 factorial ways.
Okay. All right. Thank you so much, sir.
Okay.
Sir,
Anything? Yeah.
Sir, activity 6.1, question number 1.
I think it's a true false one, right?
Yes.
Yeah. So yeah, here the question says that in how many ways can the 6 question be attempted, right?
Yes, sir.
So for each question, either you can answer true
Or false.
Or you can leave it. I have not done it. Okay,
Yeah.
that's also an attempt, right?
So 3 to the power 6.
Yeah.
Oh, yes. Okay. Sir, last one also. Last second. Yes, third one.
Third one.
Yes.
In how many ways can 4? I think it was 120. Yeah. It's the 5 factorial only, right? Okay. Let's see. How many rings were there?
But 4 rings are only.
4 non-negative rings can be okay. Okay. So okay, you have 5 fingers, right?
Yes.
One, two, three, four, 5. Okay, let's me take the first ring. Okay, let's R1. It can go to any of the 5 rings.
Yes.
So 5 fingers. Second can go to any of the 4 because 1 is occupied by this. Third can go to any of the 3. And 4 can go to any of the remaining 2.
Oh,
and one is not. Okay. Thank you, sir.
The conceptual one.
Yeah, please ask.
NC1 is NC2 into NC3.
Your voice is a bit low. Can you
Hello.
please? Yeah.
Am I audible, sir?
Yeah, now it's audible.
Yeah, we use NC1 into NC2, NC3 into NC4 is equal to 2 to the power n minus 1. How it is arrived, sir?
It's NC0.
Yeah.
Okay.
2 to the power
n. Yeah, it's the thing.
Yeah. How it is?
It's okay. Let's just do it by some simple stuff. Okay, you have a plus b whole square. Okay.
Yeah.
So for that we do is 2c0, a to 0, b ratio over 2. Okay. Plus 2c1. This one goes here, and here it's 2 minus this thing. Okay. Plus 2c2, a2, b0, right? Let's just open it. This 1 times b square plus 2ab plus a square, right? That's the formula for a plus b whole square, right? But when I do this thing, I can say that 1 raised to the power 0 times 1 raised to the power n. 1 raised to the power 1, 1 raised to the power n minus 1, so on. And C1, 1 raised to the power n, 1 raised to the power. So it's 1 plus 1 whole raised to the power n.
Okay.
So 2 raised to the power n. Okay, if you replace it by a and b, then it will be a plus b whole raised to the power n. That's just an expansion.
That's why we directly use him. Yeah.
Yeah.
2 to the power n.
Yeah.
Okay. Thank you, sir.
Sir?
Yeah.
So we have to take this concept of leaving in every question. Like we can assume like he is leaving one question, like options of.
Can you tell me question any, like I couldn't get your.
Like in first question, it is not given that leaving one part.
Yeah, here it's clear, right? In how many ways can question attempted, right? So if you are giving question, it's possible that you may answer either true or false or will leave it, right? If it's mentioned that he has answered all the questions, then it's 2 to the power 6, right?
Okay.
If it's mentioned that he has answered all the questions, so such you have to read the statements carefully to make the cases. That's the only thing in B5 and 6.
Yes, sir. Thank you.
Okay, I think we can end it then, right? Okay.
Yes, sir. Thank you.
Thank you, everyone.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir. So nice, sir.
Thank you, sir.
Thank you.
Hello.